All right, guys, for our last example, it says Joaquin believes he should be the team captain for shot put. Now, shot put, for those of you that don't know, is a sport where a strong person throws a very heavy iron ball as far as they can. Joaquin's main competition for this is Damien, the current captain. After looking back at their practice records, Joaquin noted that in his last 20 throws, his average was 15.94 meters with a standard deviation of 2.1 meters. For Damien's last 20 throws, the average was 15.75 meters with a standard deviation of 2.3 meters. With an alpha level of 5%, is there sufficient evidence to support Joaquin's claim? So I've taken this information and put it over here on my document. And again, we're just going to look for some important information. Now, the first thing we want to do is take a look for our hypotheses. And in our hypotheses, we need to figure out which one is being stated by the claim. Now, if you haven't noticed yet, for almost all of these that I've done, I've made them so where it's pretty much the same hypotheses and same claim each time. It's going to be you choose one person as one person is two, and then you say, well, if this person believes they're better than the other person, then they are greater than that person. So in this one, Joaquin believes he is better than Damien, and he wants to be captain. So let's go ahead and make Joaquin number 1. So we are going to put mu 1 is greater than mu 2. And this is, of course, our claim because this is what Joaquin is claiming. Now, the opposite to this, again, we just need to flip the sign and put a line under it. So we'll do that. We'll say mu of 1 is less than or equal to, let's try that again, less than or equal to mu 2. All right, we have our two hypotheses. We know that the first one is our claim because this is what Joaquin is claiming. This is, of course, its opposite over here. So if we can reject this one, we can support this one. Now we need to find out if we can reject it. So first thing we're going to look at is our alpha level. It says alpha level of 5%. So let's go ahead and put that 5% there, 5%. Next up, we need to find our T of alpha. Now remember, we're going to use T distributions because if we take a look at standard deviation, nowhere does it say population standard deviation. It just says regular old standard deviation. So we have to assume this comes from the sample that we took. So we will be using a T distribution. Now we can do this pretty easily by bringing up our T chart, which I have right here, and we're going to look at where 5% on a one-tail meets our degrees of freedom. Now we don't know our degrees of freedom yet, but we can find it because each of these gentlemen, we're looking at the last 20 of their throws. So these are our n's. So if we know that our n is 20, that means our degrees of freedom is 19. And we're going to find out where 19 meets a single tail 5%. Well, single tail, one tail, 5% is going to be the second column. And we're going to go all the way down to 19, which is here. We're going to follow that to the second column, which gives us 1.729. Let's go and write that in there. 1.729. And we know that this is going to be where our rejection zone begins. All right, let's just fill in everything we know. We know the averages. Joaquin's was 1594, 15.94 meters. Damien's was 15.75, so 15.75. Standard deviation for Joaquin was 2.1. And for Damien was 2.3. We're going to square each of these values. So 2.1 squared, let's find that out real fast. 2.1 squared is 4.41. Now we do the same thing with 2.3. So 2.3 to the second power, also known as squared, is going to be equal to 5.29. All right, we've already established that N1 and N2 are both equal to 20 since we were looking at the last 20 throws that each of these gentlemen made. We have all the information we need to solve. So for the first thing we got to do is find our standard error. Well, standard error we're going to find by taking the variance of our first gentleman and dividing that by 20. So our variance was 4.41 for Joaquin. And as we said, 20 was our n. For Damien, we had 5.29 as our variance, and that was also over 20. Let's go ahead and find out what 4.41 over 20 is. That's going to give us approximately 0.2205. 0.2205. We're going to add that to 5.29 over 20. 5.29 divided by 20 is going to give us 0.2645. 2645. All right, if we add these two numbers up, we will definitely find out what is underneath the root, and then we can just square root it. So 2645 plus 0.2205 is going to give us 0.485. Let's go and square root that number. We get 0.6964. Let's call that 0.70 approximately. So we're going to say approximately 0.70. All right, we now have our standard error. The only thing we have to do now is plug everything else in. So on the top, we know that these two mu's are going to just completely cancel each other out. So they're completely pointless to think about. But x1 minus x2 is going to give us 2.1 minus 2.3. Sorry, no, it won't. It's going to give us 15.94 minus 15.75. 15.94 minus 15.75. And those are all going to be over our standard error, which is 0.70. All right, well, let's find out what's on top. 1594 minus 1575. It gives us 0.19. 0.19. And that's going to all be over 0.7. So 0.19 divided by 0.7, it's going to give us approximately 0.27. And this is our sample statistic. Now what we can do with this sample statistic is we can plug it in and take a look at it on a curve. Now we do know that our alpha levels t-score is going to be 1.729 and our sample statistic will be 0.27. So let's take a look at how that would look on a curve. So let's put our alpha level at 1.76 approximately? 1.729. Okay, so 1.729. 1.729. So we'll say it's right around here. That means everything to the right of it will be our rejection zone. So we can draw rejection zone is going to be around here. So we can imagine all that's all shaded in as a rejection zone. Okay. We'll call this area over here the rejection zone. All right, now we have to put our other sample statistic in there, and that was at, I believe, 0.29, 0.27. Okay. And we know that 0.27 will be actually be pretty close to 0. So we'll call it right around here. And we'll label it as 0.27. All right, well, as you can see, our sample statistic is not actually in our rejection zone. That means we cannot reject the null hypothesis. Let's write that out. Cannot reject the null hypothesis. And if we cannot reject the null hypothesis, then we certainly cannot support its opposite, which is the alternative. If we cannot support the alternative, and we know that our claim is in the alternative, then unfortunately we cannot support our claim. Now, why is this? Because clearly, if we go back to the work, it looks like Joaquin was doing much better than Damien. Well, if you look at these numbers, they're actually pretty close together. Joaquin is only about 0.2 meters above Damien, and that's based on an average. And if you look at their standard deviations, are also pretty close to each other. So these two gentlemen, even though Joaquin looks like he's a little bit ahead of Damien, we can't say for certain that in all circumstances, maybe if they went back 30 or 40 or 50 different trials or getting the samples that far back, that Joaquin wouldn't fall behind Damien or Damien wouldn't push forward. The two numbers are just so close together that there's not enough evidence to support the claim that for sure Joaquin is better than Damien. So let's go and write it out. With an alpha level of 5%, we do not have sufficient evidence to support the claim that Joaquin is a better shot putter than Damien. All right, guys, that's the answer. Thanks for watching.